Hi, my name is Will Krawczyk, Scientific Services Manager at Chemical Computing Group. Today I'd like to introduce the docking tools that we have in Mo. In this session we're going to be using Pharmacophore-Guided Docking to dock a library of ligands and ensure that we're generating high-quality docked poses with all key interactions preserved. So let's get started. So I'll just go ahead and use the Open button on the right-hand side button bar to retrieve the file that we're going to be working on today. And once I select that in the Open panel and hit OK, it appears in the main Mo window. But before we can even think about docking, the very first thing we need to do is go ahead and prepare our model. So I'll use QuickPrep, our automated preparation wizard, for this process. The panel comprises three main sections. The first handles the preparation and cleanup of the structure. Second sets tethers and restraints, and the third handles refinement. So I'll just accept the defaults and hit OK here, and I get a message at the top left of the main Mo window to tell me that the calculation has been initiated, and it also gives me a progress update. I'd just like to take a moment to reopen the panel so I can explain what's going on in the background, or rather what just happened in the background. Because the calculation is complete, the message has gone from the top left of the main Mo window. So the preparation stage ensures that we have a complete model. Here we add in missing hydrogens, charges and side chains, and we also build any loops that might be missing within our model. Protonate 3D optimizes the ionization states of the bound molecules together with their side chains. It also optimizes the placement of polar hydrogens so that we can generate a hydrogen bonding network. By default, we tether any atoms within the active site, and the reason that we do that is to ensure that we can retain the original geometries of those atoms as they were captured by crystallography. We don't want to lose those to processes such as energy minimization. Likewise, atoms that fall outside of the active site can be fixed, and we can do that for reasons of computational efficiency, and the final refinement step performs an energy minimization to ensure that we don't have any clashes in our structure. So with the calculation complete, I'm going to cancel that panel, and the next thing that I'd like to do is hit Site View on the right-hand side button bar. That isolates the ligand together with any residue within 4.5 angstroms. And next, I'd like to adjust the rendering of my display. So for that, I'm going to access the System Manager, and I'll pin that to the main Mo window as a means to manage all of the data that we have in our system. From here we can hide and show different atom sets, we can make selections, we can also render and generate surfaces. So I'll use the rendering option, I'll render our ligand in pink so that it stands out a bit, and next what I'd like to do is analyze our complex so that I can understand the key interactions between ligand and receptor. The first place I'm going to look for that would be the main Mo window itself, where I see that Mo has automatically calculated and annotated these interactions, shown by the dotted line with a cylinder in the middle. So here we have a classical hydrogen bond. We also have a proton-pi interaction here with the aromatic feature, but Mo can also calculate non-standard interactions such as halogen and sulfur interactions. When I come to dock our series of molecules, I'll want to preserve important interactions such as that hydrogen bond with the glutamine and the proton-pi interaction. So we'll later achieve this by creating a pharmacophore. So here I see that we've got two specific interactions, but beyond that, what I'd like to do also is get an idea about the size and the shape of the binding pockets. So for that, I'm going to generate a receptor surface. You can see within the surface submenu, we've got access to some of the default surfaces available. Here I'll select the receptor surface, which is color-coded by atom type. Predominantly grey for the carbon, but we also pick out reds and blues corresponding to the oxygens and the nitrogens. So here I can see the scope that we have to accommodate different ligands within this binding pocket. And now that we've prepared the model and we've adjusted our visualization, we can start to think about docking. What we'll do next is dock a small library of ligands to this pocket, and we can guide the process using pharmacophores. The process that I show you can be applied to any ligand or collection of ligands. So before I launch the dock panel, I'll just go ahead and clear our surface And then we can take a look at the dock panel, which itself is a unified docking application that we have in Mo. Using this one panel, we can perform different types of docking. So we can perform the general protein-ligand docking, which is what we'll explore today. We can also do template-based docking. We can dock to electron density. We can do reaction-based covalent docking, protein-protein docking, and then finally we can dock using external programs. And you notice that as I click through these different docking methodologies, the top part and the bottom part of this panel stays pretty much the same. It's the middle part that changes according to the docking methodology. And this is deliberate in the design so that once you're familiar with one type of docking methodology, you'll be well placed to go on and consider a different type of docking methodology. In all cases, the top part of this panel allows us to specify the receptor settings, the middle allows us to specify the ligand, and the bottom handles the refinement and scoring. So I'm just going to move this to one side, and now we can have a look at these options and settings in more detail. So starting at the top with the receptor, we see here that the receptor is leveraging the Mo system. We only have one receptor in the Mo system, so this is exactly what I want to dock to. But we do have some options. So for example, if I click on this pull down, the main option that we have here is whether we want to include solvent atoms as part of our receptor environment, or whether we want to just select the receptor atoms alone. Here I can see that we've got some water molecules present within the active site, so for that reason I'm going to keep the default of receptor and solvent so that we can dock to that pocket as is. Next we can define the binding site. So rather than docking to the whole structure, which is not very computationally efficient, we can define the binding site, which currently is defined by default by the ligand atoms. So the ligand, in this case, it's a co-crystal structure. The ligand is bound to the orthosteric site, so this is a sensible choice and one that I'd want to use. But in some examples, perhaps I'm handling an allosteric binder, perhaps it's an apo structure, so I can use this drop down to select different sets of atoms that would help me to define that binding site. Next, I can define a pharmacophore, and we can do that for the purpose of guiding the docking process. So in this example, we have the benefit of our crystal reference. We already identified that we've got a couple of specific interactions. So what we can do next is code the hydrogen bond that we saw here, the proton-pi interaction, and that's going to assist in the placement of our ligand library. So we can preserve those contacts by creating a Pharmacophore query to use in the docking run. If I click on the Pharmacophore pull down, you'll see we have an option to load in an existing Pharmacophore file, but today I'm going to show you how we can create a new query, and I'll open the editor so that we can do this on the fly. So the Pharmacophore Editor allows us to add, remove and modify query features from either the receptor, solvent or ligand. And the features that we generate will soon be populated in the center of this panel and will help us filter our docked poses. You'll notice in the main Mo window that our ligand has been updated to show us annotation points. And these annotation points are color coded, such as the acceptor annotation points are shown in cyan. We've got donors in magenta. We've got aromatic shown in orange and hydrophobic in green. And you'll notice that some of these annotation points don't sit directly on the ligand. Some of these are projected features and they give us an idea about directionality. You'll also notice that there's more than what we actually need, so it's down to us to decide which of these annotation points are important, or in other words, which key interactions do we want to preserve when we dock the library of ligands. So in this case, if I just move my Pharmacophore editor to one side, the first annotation point that I'm going to select would be the center of this aromatic ring. So I'll go ahead and create a feature from that. Now next I need to decide which of these oxygens are going to be interacting with our receptors. So rather than second guess which one of these annotation points or projected annotation points I should be using, what I'm going to do is just toggle off the ligand annotation points, and I'll make my selection on the receptor instead. So I'm just toggling on the annotation point for the receptor, which allows me to select the annotation point sat directly on the receptor and generate a feature from that. So that's it. We've generated our pharmacophore. I could go ahead and save that, but if I just go back to the doc panel, I can see that the pharmacophore entry within the doc panel is pointing towards the editor. I can see that these features are active within the main Mo window. So for that reason, I won't save. I can just move on. But before I move on, I just want to make a point to say that we don't need to generate a pharmacophore to do docking. Here, today, I've opted to leverage the data that we gathered in the analysis of this co-crystal structure that can help ensure that we generate high-quality docked poses with all of the key interactions preserved. So that was the receptor part of the doc panel. I'm now going to move on to the ligand settings. So here we can dock using ligands from the system manager, and I can see that the ligand entry is saying to use the Mo system. Now in this case, we've only got one ligand within our system manager. So if I was to run with the defaults, this would perform a self-docking exercise where we'd be redocking Rolipram back to that receptor. I do have the option, however, to load in a database of ligands by clicking on this folder button. That could be an MDB, SDF, or OEB format. I could even select multiple databases. I could also use this benzene ring icon, which would open the sketch tool and allow me to define a new ligand on the fly. Today, though, I'm going to load in a library of ligands, and I'll navigate to our sample mol directory and just select a library. So this is a library of just only 7 ligands, so it's a small database of known PDE4 inhibitors. But the method that I show you can be applicable to much larger libraries, whether we're docking 7,000 or 7 million ligands. So the third and final part to the doc panel is the placement scoring and refinement. So currently, by default, we're going to dock to a rigid receptor. We do have the option to change this to induced-fit, and that will allow me that allows the receptor to flex during the final refinement stages of docking. However, that is computationally expensive. I'll just take a moment to explore the scoring functions. So we've got GBVIWSA, which is selected by default. This is our publish method, but we do have different scoring functions that can be written to the output database. And also we can change the number of poses. So with this being a demo, I'm just going to reduce the number of poses that we're generating in our docked run, although I wouldn't normally do that. And I'll go ahead and click run. When I click run, I see a message at the top left of the main Mo window, which gives me a progress update on the docking run. And 3 things are happening here. So in the background, Mo is generating confirmations and placements of our library of ligands. It's starting with ligand 1 of 7. And what we see on the screen here is that it's generating refinements of the best placements. You'll notice that a database viewer has been opened. That's where the results will be written. And once the process is complete for the first ligand, it then moves on to repeat that process for the second until it gets to the end. So I'll just go back to our doc panel. If I just pull this to one side. And just explain that today we're docking a small library of 7 compounds, but if we were docking a larger library, we might want to consider using this batch button. What that would allow me to do is take the input parameters that we've specified in the doc panel and write this as a run file so that I can run that on a cluster, perhaps at a later date, or maybe I want to send it directly to the queuing system. So that's the batch button which would allow me to do that. Today, we're using our docking run in conjunction with the Pharmacophore, which means that after the pose generation and refinement steps of the normal docking procedure, any final poses that do not satisfy the Pharmacophore, so in this case, having an aromatic region here and an acceptor pointing out towards the receptor environment, if any poses don't have those two features, then they will be omitted from the results, so they won't be included. Today we've generated quite a simple 2-feature Pharmacophore, but in practice you may want to play, generate and test your own Pharmacophore hypotheses. So you'll notice that the results are being written to a database viewer. This looks and feels much like an Excel spreadsheet, but if I just drag the mol field open, you'll see that it actually contains the structure of our ligands. This would be our main window for viewing database entries and also our launching point for things like QSAR. Here we've got the results written for each of our ligands, which are defined by mseq, a unique identifier for ligand 1, 2, 3, and so forth. And I'll just point out here this S field. So this represents affinity or a score. You can liken it to affinity or a binding affinity, a measure of how well the ligand is interacting with the receptor environment. It's an energy, so the more negative this value becomes, the better the interaction. Within the database viewer, other results have been written, such as the RMSD refine, so how much the ligand moved during the refinement steps of the docking process, and together with some other predicted and calculated values. But what I find useful is to go ahead and open a database browser. And what this allows me to do is browse the docked conformation of our ligand in the 3D environment, as well as displaying this 2D schematic so that I can have a look at this one entry at a time. So here we see, if I just move my browse panel to one side, we see the docked pose shown in green against the co-crystal structure shown in pink here. I can add different parameters from the database to the database browser. So if I add S for score, perhaps also I'd want to keep an eye on the unique identifier. I can stack up several of these parameters if I wish. And in this case, this ligand is the same as the co-crystal structure. And we can see that we've got quite a good superposition between the two. And as I start to click through to have a look at some of the different poses, you'll notice that the score slowly drops off. And now we're looking at the second ligand within this series. And we can go ahead, perhaps we want to keep some of these, so I can click keep to send that particular pose to the system manager. Or perhaps I want to select, so that I can select it in the database viewer, interesting poses that I might want to come back to at a later date. And from there, perhaps what I'd like to do is go ahead and save that. And I can save those selected entries as a subset. So today we've seen how to dock a library of ligands to a receptor. We also saw how to use pharmacophores to help guide the docking process and ensure that key interactions are present in all of our docked poses. I hope that you've learned a lot today. If you have any questions, please do reach out to me at support@chemcomp.com.